Okay, hello everyone, and welcome. We're just going to review probability of multiple events here today. So a lot of today is we covered some of it yesterday. I just want to cover it again, okay? In today's essential question, I think it's the same as yesterday. How does the relationship between two events affect their probability of occurring? Let's look at an event. Event is just an outcome. It's like a happening. It's something that we can observe or put a measurement to it. Say it happened or it didn't happen. All right? Toss a coin, roll a dice. All right, these are the three types of events we talked about: independent, dependent, and mutually exclusive. There's the definitions right there for you. Guys, again, independence. Each event is not affected by some other event. Like when you toss a coin, the second toss of the coin is not affected by the first toss. If you throw 4 heads in a row, that doesn't mean that the next one is going to be tails. The probability is always 50-50 when you throw a coin in the air. Guys, but some events are dependent. Like if you draw 2 cards from a deck, right? If the first card is a king, then the second card is less likely to be a king. You're not replacing it. Again, if you replace it, then the events become dependent. But in this case, the second selection from the deck, there's only 51 cards left. And if the first one was a king, well, then the second selection, there's only 3 kings left. Guys, dependent events, we sometimes make a tree diagram. I just want to show them to you. It's kind of a preview from something that we're going to be doing next week. All right, you can use tree diagrams with dependent events to calculate different probabilities of multiple events, known as conditional probability. As we also talked about mutually exclusive, it's very important here today. I want to go a little heavier into this. Again, guys, it means that we can't have both events happen at the same time. All right, like turning left or turning right, or a heads and a tails, or a king and an ace. You can't get them at the same time. However, a king and a heart, you can get it at the same time, because you can draw the king of hearts. One event, all right, both things can happen. All right, let's look at the probabilities of mutually exclusive events, okay? Remember, probability is a fraction. It's a ratio, guys. The number of ways something can happen, the thing you're measuring, and the total number of outcomes that you're keeping track of. All right? Guys, if there's 4 kings in a deck of 52 cards, what's the chance of picking a king? Well, it's a probability, 4 over 52, okay, which reduces to 1 out of 13. You know, when 2 events are mutually exclusive, they both can't happen at the same time. All right, so the probability that A and B happen, if they're mutually exclusive, it's 0. All right? However, you can draw a king or a queen as an example. You can't draw a king and a queen at the same time, but you can draw a king or a queen. You can do that. All right? The probability of drawing a king or a queen, or 2 events, one or the other, if they're mutually exclusive, you can add up the 2 separate probabilities and get the probability that either one of them happens. And the probability of getting a king is 1 over 13. The probability of getting a queen is also the same thing, 1 over 13. So the chances that we get a king or a queen, add them together, it's 2 over 13, choosing one card. We talked about Venn diagrams. I just want to review the upside down U. All right, that is intersection. All right, that means and. They both have to happen, and. All right, a right side up U or a regular side U, like this right here, means that or either one of them can happen. And when you do that and they're mutually exclusive, you can add the two probabilities together. All right. Again, the probability of scoring no goals or one goal. All right. They can't do them both. They're either going to score one goal or they're not going to score any goals. They're going to score something. All right. But if you want to know the probability that they score 1 or 0, you can just add up those two probabilities. Also, again, very important here, some events aren't mutually exclusive. We talked about the King of Hearts. All right? You can pick a king and a heart at the same time by taking the King of Hearts. So those two events, drawing a king and drawing a heart, they're not mutually exclusive. All right? So if we add the two probabilities up and say, what's the probability of getting a heart or a king? If you add them up, we count the King of Hearts twice. All right, so the formula then, if they're not mutually exclusive, all right, for the or, either or event happens, is you add up the probability of the two events happening, then you subtract the probability that they both happen. All right, we have to subtract that one extra king out because we've added it twice. All right, that's the formula right down there. And we'll use it. As a quick final example, sometimes it looks like this. We're saying that 16 people study French and 21 study Spanish. And there's 30 people altogether. Well, that means that some people must study French and Spanish. Right? So you can set it up like this. There's some number in the middle that study both. It says here 16 people study French. So the ones that study French only must be 16 minus B. And since 21 total study Spanish, the amount that studies Spanish only is 21 minus B. You can set up a formula here, and we'll do some of this in class and find out what B is. Because once you get the Venn diagram set up, you see how nice this is? You can solve all the probabilities just by looking at the Venn diagram. And this is a good way to help prove the formula we just learned. The probability that they study French or Spanish, that's 100%. That's all of them. They all study French or Spanish. So the probability that they study French is 16. The probability that they study Spanish is 21, over 30. And then you have to subtract out the 7 over 30. So we end up with 30 over 30. I know it's a lot there. Guys, here's a little summary for you. This one has to do with just the mutually exclusive and the not mutually exclusive. And this again is the formulas we looked at, some of them yesterday too. Again, independent events, you multiply them together if you want to know the probability that they both happen. All right. Dependent events, we will look at that later on. Okay, don't worry about this one right now. The mutually exclusive and the not mutually exclusive. All right, that's it. Guys, please complete the homework check in the purple folder. And these are the 4 vocabulary words today for the warm-up. They'll be matching. All right, thank you.